These exercises are designed to help you work through problems on the time value of money. The whole idea here is that a dollar today is worth more than a dollar tomorrow. So we need to be able to adjust for time when comparing amounts across different time periods. One of the things that we're going to see that makes the calculation a lot easier are present value tables, which are included within Appendix C of your text. In these problems, we're going to need to know some basic information. The first piece of information is labeled P, which stands for principal, which reflects the amount borrowed or invested. I, which is an annual interest rate, or N, and N, which reflects the number of periods we're talking about. Now note that this is usually expressed in terms of years, but it doesn't necessarily have to be, as we'll see. Now when doing one of these problems, we have to figure out which of four possible things we're actually looking for in the problem. First, we could be looking for the future value of a sum, or how much an amount of money today will be worth in the future. We could be looking for the present value of a sum, which is how much an amount of money in the future is actually worth now. We could be looking for the future value of an annuity, which is how much a number of periodic payments will have accumulated at a future date. Or we could be looking for the present value of an annuity, which is how much an amount of periodic payments in the future is actually worth now. So let's go ahead and go on to the questions. In this exercise, question 1 asks us how much a sum of money will be worth tomorrow. Flanders won a bingo tournament, and we have to see how much money he'll have built up if he puts it in the bank for 15 years. And so what we need to do is put in some of the information that we've got. So we can put in our principal amount of $25,000. We know that the interest rate is 4%, and we know that we're talking about 15 periods. And so we're really looking to get the future value of a sum, so we can actually use Table 1. So what we're going to do is go to Table 1 and try to find the intersection of 4% and 15 periods. And so what we can do here is find that the intersection of the two gives us a factor in this case of 1.80094, and so our factor is 1.80094, so that and what these factors do is it just makes us have a pretty easy calculation where if we want to know the future value, we can just take our principal amount and multiply it times this factor, and the compounding will have already been done for us. So we can take our principal amount of $25,000 and multiply it times that factor of 1.80094, and we know that if Flanders had left the money in the bank, then it would have built up a total of $45,023.50. Next, we can think about present value. Suppose Flanders wants to be able to go on vacation in the future, and he knows that vacation is going to cost $10,000 in 3 years. So now we're targeting building up $10,000. The interest rate in this case is 5%, and we're talking about 3 distinct time periods. And since in this case we're trying to figure out how much a sum of money in the future is worth now, this is getting at the present value of a sum. So if we want to use the right table, we're going to have to scroll down to Table 3, because we're looking for the present value of a dollar. And so what we're going to do is again find the intersection of 5% and 3 periods. And so we see that the intersection is a rate of 0.86384. And so now to calculate the present value, we can take again our targeted future value amount of $10,000, and we know that our factor is 0.86384, and so we can multiply that times our future value amount. And so that means that we would need to put $8,638.40 in the bank if we wanted to be able to go on vacation in 3 years. And continuing on with our discussion on this present value problem, I just want to make one extra observation. Notice that to be able to go on a $10,000 vacation in 3 years, we actually need to put less than $10,000 in the bank now. And that's based on the whole idea that a dollar today is actually worth more than a dollar tomorrow. And so the present value of a future sum is generally going to be lower because of that fact that a dollar today is worth more than a dollar tomorrow. So in this case, we only needed to put $8,600 in the bank so that by the time 3 years would have passed, we would have $10,000 built up. So now we can move down to the next question, and now we're going to start talking about annuities. And annuities are similar to the principal amount, but instead of there being a single sum, we're talking about a payment that happens every period. And so the example that we went through in class is that an example of an annuity would be a yearly Christmas check from grandma, or a yearly tuition payment, something that happens at the same amount every year. So question 3 says that Flanders is trying to figure out how much a series of insurance payments made in the future is actually worth now. Now we know that the amount here is that Flanders is going to make a $100 payment every 6 months. But one of the things that can possibly come up is that payments are not made in annual increments. In this case, we have to make our payment every 6 months. And so even though this happens for 5 years, we're actually going to make 10 distinct payments because we're going to make 2 per year. And so n in this case is 10, but interest rates are stated in terms of annual rates. And so to be able to have the interest rate stated correctly, you'd actually need to cut this in half and make your interest rate 4%, because it's really 4% every 6 months. And so since here that we're talking about the present value of an annuity, we're going to be able to go to our tables, and we're going to be using table 4 in this case. And so we're going to be looking for the intersection of 4% and 10 distinct time periods. And so we see that our rate is 8.1109. And so our factor is 8.11090. And so the annuity table is actually built in the fact, they build in the amount of the individual payments as well as accumulated interest. And so we can just take 100 and multiply it times our factor of 8.11090. And so in present value terms, those 10 insurance payments are worth $811. Now note that this is less than the value of the principal payments, which would be $100 times those 10 payments, or $1,000. And again, that makes sense because the payments become less valuable as time goes on into the future when you're actually making the comparison to today. And finally, question 4 asks us to calculate the future value of an annuity. Flanders is worried about retirement, and so he's trying to figure out how much he'll have built up after 20 years. And so with a principal amount, a yearly payment amount of $16,500, an interest rate of 6%, and 20 periods, this sounds a lot like the future value of an annuity. And so we're going to be able to use table 2. So we're going to go and scroll up to table 2. And we're going to look for the intersection of 6% and 20 periods. And so we're going to see that this intersection gives us a rate of 36.78559. And so our factor is 36.78559. So we can take our yearly payment amount of $16,500 and multiply it times that 36.78559 and get a future value amount of $606,962.24. And note that this is actually more than the sum of the principal payments. If you take $16,500 and multiply it times 20, you get $330, and that reflects the compounded interest.